So welcome to lesson 12. In this lesson, we are going to review our index laws and how we're going to use them at a Year 10 Math Methods Prep level. So we're going to go over the 8 index laws, and then we're going to look at using multiple index laws in a single question. A really quick resource checklist before we get started. Make sure you've got a calculator, something to write on, something to write with, and a good attitude. So we're going to still need a calculator when we're doing our index laws. And as always, even if it's a really complicated question, I know you guys can do it. So quick visual cues before we start. The pen symbol means I want you guys to write some stuff down that's on the slide, or I want you guys to work through some problems. The calculator symbols means you're going to have to use your calculator to do some working. And the little laptop symbol means you may need to do something on your computer. So our work for this lesson is to revise the index laws and use indices when problem solving. So we're going to come up with some indices to answer some questions, and we're going to solve some complex index law problems. So I want you guys to look out for correct notation. We need to watch out for negatives, because negative powers mean a certain something, which hopefully you guys will remember, but we'll still go over it. And I want you guys to consistently use the rules. So that doesn't mean tell me every time. That just means make it clear that you're using index laws and you're not just writing the answer. I don't know if you guessed that answer, and when we're looking at understanding of using index laws, I need to see you've actually done them. And you know, indices are actually used in all types of mathematics. It's one of the foundational things. It's the second letter in BEMDAS or BIDMAS or BOMDAS, the order of operations, however you remember that. So indices are very important. So our index notation, when a number or pronumeral is repeatedly multiplied by itself, we write this as an index. So in our example here, we have a to the power of x. Now a is the base, so it's any real number or pronumeral, so any variable, any letter or number, or Greek letter. And x is the power, so that's again any real number, any pronumeral, so any variable. So what this means is that we have a multiplied by itself x times. So x is the amount of times we've multiplied a by itself. So there are 8 index laws, and they're used to simplify expressions and equations with indices. So in a simplifying, we're reducing the amount of terms. And prepare yourself. We're going to write down all 8 index laws. So the first law is the multiplication law. So when the terms have the same base, are multiplied, we add the indices together. So we both have a to the power of m and a to the power of n. So we both have a base of a, and we're multiplying them together, so we add the powers together. The second law is the division law. So when terms with the same base are divided, the indices are subtracted. So we have the same base again, a, and we are subtracting the powers because we're dividing here. Sometimes you may have a to the m over a to the n, and a fraction is the same as dividing. So that's something really important to remember. The third index law, the zeroth law. So any term, excluding 0, with an index of 0 is equal to 1. So a to the power of 0 equals 1. Any value in here for a, any variable, any symbol, any number you can think of, if it's raised to the power of 0, the answer is 1. Well, you can find stuff online that says 0 to the power of 0 is 1. That's the agreed idea, but special stuff happens when we raise 0 to the power of 0, so we just don't do it. So any term except for 0 raised to the power of 0 is 1. The fourth index law, that's called the power law. So when a power is raised to another power, the indices are multiplied. So it can be a bit tricky with this picture here, but we have a to the m, and we're raising this entire power, not just raising the a, not just raising the m, we're raising the entire thing to the power of n. What that means is we've got a to the m times a to the m times a to the m times a to the m, all the way until we have n lots of a to the m. And the way we can simplify that is just multiply m by n. So that's how we use the power law. The next law, the fifth law, is the distribution law. So when there is a power outside a set of brackets, you raise every term inside that set of brackets. So if I have a times b in brackets raised to the power of m, that means a is raised to the m and b is raised to the m, because these are multiplied. Now they don't have the same base, so we can't simplify this further. But when we do have brackets, this is what we can do. The sixth index law, the fractional law. So when the base is a fraction, just like with the fifth law, you have to apply the power to both the numerator and the denominator. So here, if we have a divided by b, and we raise it to the power of m, we have to apply that to both. Now, they don't have the same base again, so we can't simplify this further, but this is when we're using the fractional index law. The seventh law, the term with a negative index can be expressed with a positive index. So when I have a to the power of a negative index, I can write that as 1 over a to the n. So to remember that, if I have a term with a negative index, I can write it as 1 over that term with a positive instead of a negative. And vice versa, if I have 1 over a term with a negative number, I can write that without top as a numerator without the negative. Last but not least, the eighth law. So terms with fractional indices can be written as surds. So a fractional index is an index that is a fraction. So if I have a raised to the power of a fraction, I can rewrite that fraction as a root symbol or a surd. So if I have 1 over n, I'm finding the nth root. In more simple terms, if I'm raising a to the power of 1 over 2, then my simplified version is square root of a. So here, if I have a is to m over n, that is equal to the nth root of a to the m, which is the same thing as nth root of a all to the power of n. So just remember this one. This is the most important one. Okay, give yourself a 5-minute break. You just wrote down 8 index laws. You would have had to pause the video a few times, 8 times, to get all those down. And give yourself a pat in the back. You did good. Maybe go get a hot chocolate. You've definitely earned it. When we problem solve with indices, we're more often than not going to have to use more than one index law. So we still have to follow that order of operations. So we do brackets, multiplication and division, addition and subtraction. And then we're going to express the final answer with positive indices only. So that means we're going to have an index on the bottom of a fraction. As long as it's positive, that's okay. So remember those 3 things that we're going to have to use more than one index law. Got to remember our order of operations, and it's really nice to express your final answer with positive indices. So I'm going to go through how to simplify this problem. So that's 2 times a times b to the 4 times 3a squared b all over 3ab all cubed. So that sounds very confusing when I say it out loud, but looking at that problem, hopefully some of you may already have an idea of how to solve this problem. Okay, so now we are going to solve this problem. So we're going to simplify it. So the first thing we're going to look at is this term here, because this is the index power rule. So I'm just going to write the top line the same. And I'm going to apply the index power rule to that bottom line. So that means I'm going to apply that cube or that 3 power to everything inside there. So my next line of working out, I'm just going to simplify that bottom bit a little bit, that denominator. So my top line is still the same. So now I'm just going to write 27 instead of 3 cubed. Now over here, I'm going to evaluate this top line, or this top line down here. So I'm just going to multiply the 2 and the 3, multiply my numbers with the same base. So that means I add the powers, the power of 1 on this A to the power of 2 on this A, power of 4 on this B to the power of 1 on this B. So I'll end up with 6 A3 B 5. My denominator is the same. So now I can simplify again with my division law. So you can see here how I have an A to the power of 3 on the bottom and an A to the power of 3 on top. They are going to completely cancel out. So this term and this term are cancelled out. This is a B to the 3 and a B to the 5. So I'm just going to subtract the powers. 5 minus 3, so I'll cross that one out. I'm going to write a 2, little 2 there instead. So now I have 6 B squared over 27. I can simplify this further because I know these both can be divided by 3. So that is my answer. So I've had to use the index power law, the index multiplication law, and the index division law to get my answer. So that's the more advanced stuff we're going to end up doing. That wraps up our lesson on index laws. So I want you guys to complete the worksheet, lesson 12, index laws. And I want you to remember to solve problems slowly. Apply each rule in a single step. So what I've done there, I did the distribution law, then I did the multiplication law, then I did the division law. That was so I didn't get confused about what I was doing. And if you do have questions, you can email me, you can post on Teams, or you can post in the OneNote if you need any help. Like I said, if you find another YouTube channel that explains index laws, or a sibling or another teacher explains it a lot clearer, that's totally okay as well. So good luck. You guys are good at doing your index laws.